Howdy, 8th grade. Today we're looking at multi-step absolute value problems. So we've solved some absolute value problems before. A lot of the ones we've solved have actually been multi-step, but we're going to look at these a little more in depth today so that we can do it a little better. So most of this is going to be review. So kind of a quick walkthrough. Things we should already know is that our first step we're going to want to do is to isolate our absolute value. After we isolate our absolute value, we can split our equation. We're going to make one negative. And after we make one negative, we can solve both equations. So normally, absolute value will have two solutions. Sometimes it has one, sometimes it has none. We're going to look at that today. Like when it only has one solution, and the really scary one when there are no solutions, what are we supposed to do? So we're actually going to start with one that has some solutions, just so we can get back on how this works. So my first example is going to be the absolute value of x divided by 5 plus 3 equals 18. So what I'm going to want to do is to get my absolute value by itself. So this absolute value here, I need to isolate, get it by itself, and it's being divided by 5 and added by 3. It's always easier to get rid of the addition first, so that's what I'm going to do. And I look at this, after subtracting the 3, that'll cancel. I get absolute value of x over 5 equals 15. So now my absolute value of x is being divided by 5. Can't have that, so to get rid of it, we can do the opposite, which is to multiply. So multiply both sides by 5. I'm going to get the absolute value of x equals 15 times 5, which is 75. So I've finally isolated my absolute value. Now that that's done, I can make I can split the equation into an x equals 75 and an x equals negative 75. So I made one negative, and the other one gets to stay positive. And after that, I am pretty much done. So I'm supposed to solve these equations, but they're already solved. So I can just write x equals 75 or negative 75. So x could be either one of those, and our equation would hold up. Let's keep going a little bit. So if I have a maybe more complicated equation going on, I could have 5 absolute value of x over 2 plus 4 equals 4. And we'll see what this does right here. And for this one, I'm going to start by subtracting this 4 here, because that's going to make my life real easy. So if I subtract the 4, real easy to do from both sides, this will cancel out. And actually, I have a positive 4 minus 4 on the other side, which will also cancel out. So now I have 5 absolute value of x over 2 equals, and there's nothing left over there, 0. So what I want to do now, I have it all divided by 2, so I can multiply both sides by 2. And that'll cancel this out, and 0 times 2 is still 0. And now I have this 5 here, and I can divide both sides by 5 to get rid of it. And 0 divided by 5 is still 0, so we get absolute value of x equals 0. I can split this up, and I get x equals 0 or x equals negative 0. But negative 0 is just 0. So really, x equals 0 is my only answer. This is one of the few times I will only have one answer with an absolute value problem. Moving on to one more kind of crazy problem. This one's going to be the one with no solution. Just going to warn you ahead of time. Is for this equation, I'm going to have 2 absolute value x over 6 plus 3 equals 1. So I'm going to start by subtracting the 3 out, so it'll cancel. And that'll give me 2 over 6 absolute value of x equals 1 minus 3, which is negative 2. Now I can multiply both sides by 6 to get rid of the 6 on the bottom there. I'll get 2 absolute value of x equals negative 12 Dividing both sides by 2 gives me absolute value of x equals -6. Now looking at this, I see a problem. And that problem is that absolute value means the positive number. So this is always positive. But over here, this is negative. So this is telling me that my number, which is always positive, has to be negative. And that doesn't make any sense whatsoever. So this is going to have no solution, which sometimes we write as the empty set, which is 2 brackets with nothing in between, or you can write no solution. Doesn't matter to me, whichever one you want to do. And we're going to do one more kind of complicated one, and then we're going to be done for the day. So my last example here is going to be what we want to do if we have something a little more complex. So 5 absolute value of x over 3 minus 2 equals 15. My first step is still going to be to isolate my absolute value. I'm going to do that by dividing by 5. And now I'm going to have the absolute value by itself equals 3. And at this point, it's isolated, so I can split this up, and I'll get x over 3 minus 2 equals positive 3, and x over 3 minus 2 equals negative 3. So I can split this up, and one of them I'm going to make negative, the other is going to stay positive. Now I just have to solve for x, which is going to look a lot the same on both sides. So I'm going to add 2 in both my equations to cancel out this 2 here. Let's focus on one equation at a time. So I'm going to focus on this one. So my first step is going to be to add 2 to get x by itself. And I'm going to end up with x over 3 equals 3 plus 2 is 5. And I need to multiply by 3 to cancel out the division. I'll get x equals 5 times 3, which is 15. On my other side, I've added 2. So I have negative 3 plus 2, which is negative 1. That's going to be equal to x over 3. So now to cancel out the 3, just like we did on the other side, I'm going to need to multiply both sides by 3. And I'll end up with x equals negative 3. So my final answer will be x equals 15 or negative 3. And just like that, I am done. So that's pretty much what all these equations look like. I think we've already worked through a lot of stuff that looks like this, so I'm hoping it was mostly review, nothing too terribly hard. But in any case, I will see y'all in class, and have a great day.